In our previous lecture, we were introduced to the derivative of a function. And we had learned how to compute the derivative from first principles, meaning by taking the limit given by the formula. So we had seen that f prime of x was equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is what we refer to the formula from first principles. Today we are going to be discussing the basic rules of differentiation, and each of these basic rules can easily be derived from the first principles formula. But of course the basic rules of differentiation will now make your computation more easier, since you wouldn't have to go through the tedious process of computing the limit of that expression. Right, so the first rule that we're going to be referring to is the derivative of a constant. So if c is a constant, then the derivative of c with respect to x is then equal to 0. And this can be easily derived by letting f of x equal to the constant c and then finding f prime of x using that definition. The second rule is called the power rule, and we use this rule whenever we have an expression of the form x to the power n. So the derivative with respect to x of x to the power n is then actually equal to the exponent n times the times the base x raised to the power n minus 1. Once again, this formula can be derived from first principles. The second rule is a constant times a function, and this is actually an extension of the power rule. So whenever you have a constant times your function f of x, then the derivative with respect to x of c times f of x is equal to c times the derivative with respect to x of the function, meaning it is c times f prime of x. And finally, the sum or difference refers to the following. So if you have the sum of two functions, let's say f and g, then the derivative with respect to x of the sum of two functions is equal to the sum of the derivatives. So it's equal to the derivative with respect to x of f plus the derivative with respect to x of g. And of course I could just write this simply as f prime of x plus g prime of x. Right, so the last line essentially tells you that the derivative of the sum of two functions is equal to the sum of the derivatives of those two functions. And similarly, the derivative of the difference of two functions is then equal to the difference of the derivatives of those two functions. So these are the four basic rules, and therefore given any type of expression for which you are required to compute the derivative, you can now make use of these rules rather than going the long tedious process of using the first principles formula. So let's look at an example. Right, so we're required to find the derivative of a function f of x given by the following. Now, before you compute the derivative, it's important to ensure that you've written down the expressions in its simplest form, meaning in a way which makes the computation of the derivative easy. So you would like the expression, for example, 2 times root of x to be written in a form similar to this. So how do we then do that? How do I get rid of the root sign but now express this in terms of a power? So then it's important to note that whenever you have let's say x raised to the power a root b, then this can be expressed as x raised to the power a divided by b. So in particular, if I had root x, we know this is root power, the second root, then this is expressed as x raised to the power 1 over 2. So a over b, 1 over 2, which is what I've got written down on the right hand side. So this means that this expression here, f of x, can now be written as 2 times x raised to the power half plus 10. And now this looks similar to what we have in the power rule. So using our basic rules, let's now compute the derivative f prime of x. So looking at what we have, this is the sum of two functions, so immediately I'm using the sum and difference rule. So this is then the derivative with respect to x of 2 times x raised to the power half plus the derivative with respect to x of 10. Looking at the first portion, this is a constant times a function, so I'm now using that rule, which means this is going to equal to 2 times the derivative with respect to x of x raised to the power half. And here, this is the derivative of a constant, so using that rule, I know that this is equal to 0. So now simplifying, I've got 2 times the derivative of x raised to the power half. This is now the power rule. So using the power rule tells me that this is going to equal to half times x raised to the power half minus 1. Half minus 1 is negative half plus 0, so I'm not going to write that down. And then simplifying, I then have that this is 2 times half, which is 1 times x raised to the power negative half. Now, in general, whenever you're writing down the solution to something, we would prefer for the final answer not to be written with a negative exponent. So it would be ideal to return it into the form of positive exponents. So now remember the other rule, that whenever you have x raised to the power minus n, you can then rewrite this as 1 divided by x raised to the power positive n. So these are important rules to keep in mind. So using that rule, this is 1 divided by x raised to the power positive half. But once again, I could now rewrite this in terms of roots. This is 1 divided by square root x, so the second root of x. And that's the final answer in there. So observe that in this question, we had essentially used most of the rules. We've used all of them. We've used sum and difference, we've used constant times a function, and we have used the power rule. So ensure that you are able to use all of them in convoluted ways. Right, let's look at the next question. So again, we have the sum and difference of functions. So using the rule of sum and difference, f prime of x is going to equal to the derivative with respect to x of the first function minus the derivative with respect to x of the second, plus the derivative with respect to x of the third, minus the derivative with respect to x of the fourth. Right, so in time, of course, you wouldn't be required to write down explicitly all of the steps in which I'm doing it here. However, I'm doing so because this is the first time we're going through the section. So now I've got a constant times a function, so that's 6 times the derivative with respect to x of x cubed. Similarly here, constant times a function, 2 times the derivative with respect to x of x squared. Similarly here, 7 times the derivative with respect to x of x. And here the derivative of a constant is 0. So now computing everything, it's 6 times 3x squared. I've used the power rule here. 2 times, again power rule, 2x. And using the power rule once again, this is x to the power 1, so that just gives me a value of 1. And simplifying, 6 times 3 is 18, so that's x squared minus 4x plus 7. Right, and that is the final answer. Of course, once you are really used to the rules, you could immediately see that the derivative of 6x cubed is 18x squared. The derivative of 2x squared is negative 2x squared is minus 4x. The derivative of positive 7x is 7, and the derivative of minus 8 is 0, as seen in here. Alright, so that's the end.